All right, we're taking a look at 1-4 today, solving absolute value equations. You probably explored this a little bit in Algebra 1, but just today should be a refresher for you. Keep in mind that when we discuss absolute value, one of the first things to kind of keep in mind is absolute value is always defined as the distance from 0, okay? So again, kind of the example they're looking at or giving you, the absolute value of a -4, or the distance -4 is to 0 is 4. Conversely, if what's the absolute value of 4, +4, it is also 4 away. So notice with each of these, there is typically going to be 2 answers. Unless your answer is, of course, 0, then there's only one answer because 0 is 0 units away from 0. So you want to keep that in mind as we explore solving and evaluating problems. So the first one we're going to look at here, we want to evaluate the function, or evaluate the expression rather, when x is -2. So all we have to do is plug in a -2 to our expression. -2 times 4 is -8. -8 minus 3 is -11. So inside the absolute value bars, we have -11. The absolute value of -11 is +11. 11 plus 7 is 18. All right. So basic type of evaluation, just remember absolute values are always positive. And again, they're the distance from 0. All right. Taking a peek at the next problem. This tends to confuse some people as far as writing it as an expression or equation, but don't let it confuse you at all. So a standard tennis racket has a 100 square inch head plus or minus 20 square inches. So if we stop right here, all right, and kind of figure out the problem on our own, plus or minus 20 square inches. So that means the smallest our racket could be is 80. 100 minus 20 is 80. Or the largest our racket could be is 100 plus 20, which is 120. Okay. So right off the bat, we know the answer on this question is going to be between 80 and 120. It says write and solve an absolute value equation to determine the least and greatest possible sizes. Okay. So the question on this case is, we want to come up with the absolute value equation to solve this. So the question is, where are things going to go? Okay. Well, keep in mind on this problem, we have an average size of 100. Okay. So I don't want the distance or the size of my racket, which is x, to stray from 100 by more than 20 square inches. All right. So again, to talk it through, the difference between the size of our racket and the average can't be, in this case it equals 20. And if you were to solve this equation, you'd have x minus 100 equals 20. You'd have x minus 100 equals -20. And surprise, surprise, we get our two answers of 100 and 80. Okay? So keep in mind, whenever it's asking you for an absolute value equation, kind of a general way to think about it is we always have the absolute value minus the average, or the distance away from that kind of center point is going to equal the tolerance. Tolerance is how far it can stray from that home base. Okay? So kind of keep that in mind as we go ahead through these word problems, because a lot of them are going to be set up that exact same way. You just need to figure out the average, figure out the tolerance, plug it in, you're good to go. As we continue on, we're going to have some more specific problems here to finish, but we're looking at absolute value equations. I'm going to zoom in a little bit so you can better see. All right. But the goal of these is to kind of treat the absolute value bars, you guys, like the variable itself. So you want to isolate the absolute value before you do anything, okay? Don't say this equals plus or minus 1. Isolate your absolute value first. So I'm going to subtract 8 from both sides, okay? And some of you at this point be like, whoa, Wagner. Here's the deal. I see an absolute value equals a negative number. That can't happen. Absolute values always have to be positive. And if you were thinking that, you are indeed correct. All right, in these instances, if you ever solve and get an absolute value as a negative number, we know that cannot happen. Okay? For those of you that didn't catch that, all right, you might go ahead and solve 3x minus 2 equals negative 7, 3x minus 2 equals positive 7. You're going to go through and solve each of those, but then when you get down here, you're going to check them, and you're going to see that neither of your answers work in the context of the question. So the two answers you found don't work, which means you could have said no solution initially. Okay? So just keep that in mind. As we're working with absolute value, we do want to get in the habit of that quick mental check to see if things are correct. All right? Last problem of the day before I turn you loose. All right? These ones are definitely slightly more complicated, but keep in mind absolute values are always positive or negative, correct? So we have two answers associated with this. We have 4x minus 8. All right, if I actually drop the absolute value bars, sorry about that. We also have the second answer, x plus 10 equals negative this side, which is negative 4x plus 8. Okay? Just like if I had the absolute value of x equals 2, you'd have to say x equals 2 or x equals negative 2. Okay? So it's that same idea that we're going to break this equation up into two parts. So we have x plus 10 equals positive this side. We have x plus 10 equals the opposite of this side. And then we just go through and solve like normal. So we'd wind up getting 3x equals 18, which means x is 6 on this side. Do a quick check. 6 plus 10 is 16. 24 minus 8 is also 16. So this answer does work. If I go over to my second one, I get 5x equals negative 2. And x equals negative 2/5. So we want to do a quick check on that. When we plug it in to the left side, negative 2/5 plus 10 is 9 3/5. And then on the other side, we have negative 8/5 minus 8 is also negative 9 3/5, but keep in mind the absolute value can't be negative. So when we plug that into the left-hand side, it is negative, and that does not work. All right? So absolute value equations again, I'll kind of zoom out so you can kind of take everything in again. Keep in mind it's the distance from 0. When you're evaluating, you're just going to plug it in and evaluate. But when you're solving equations, you're typically going to look for two answers. Be mindful of checking, because not always, things aren't always going to work. All right. And then again, when you are solving, you want to isolate the absolute value bars before you do anything. And that's going to really help you find these special cases like on example 3A. All right. Homework's listed on the bottom, but be mindful. Things do change from time to time, so please check Schoology for the correct assignment. But good luck on this lesson.